In this lesson, we are going to learn about the physics of sporting events such as baseball, boomerangs, and car racing. How does Bernoullis' principle apply to the baseball? A spinning baseball has more air turbulence on top of the ball, producing slower airspeed over the ball. Meanwhile, air moving under the ball accelerates and moves faster, producing less pressure on the bottom of the ball. The ball moves downward faster than it would normally do. What makes a ball curve? The stitches on a ball actually make it curve. The pitcher's fingers hold the ball along the seam, so when the ball is thrown with a snapping motion, it has topspin. Friction provided by the stitches causes a thin layer of air to move around the spinning ball in such a way that air pressure on top of the ball is greater than on the bottom, causing the ball to curve downward and the batter to miscalculate the position of the ball. A boomerang is a stick that returns when you throw it. To understand why a boomerang returns, we must understand the shape of the boomerang and the physics behind it. Boomerangs have its recorded origins from Australia, where the Turrawal tribe first used it thousands of years ago. The word boomerang itself means returning. Today, the boomerang is extensively used for hunting, games, and also in international sporting events. A boomerang consists of a leading edge, a trailing edge. The cross-section of the wings looks like an aerofoil. During the flight of the boomerang, the following principles come into use: Bernoullis Principle, gyroscopic stability, gyroscopic precession, and Newton's law of motion. As the boomerang flies through the air moves faster over the upper surface than the lower surface. The pressure difference that exists between the two surfaces will cause lift. The weight of the boomerang produces a drag, which slows down the motion. This reduces the time the boomerang is in flight after being launched. When a boomerang is thrown with a spin like a discus or frisbee, the spin produces two effects: gyroscopic stability, curved flight of boomerang. Formula One car racing is a high-speed sport where aerodynamics plays a crucial role. The aerodynamic drag is the dominant factor of the overall vehicle drag. For a typical car at 100 kilometers per hour, the aerodynamic drag is about twice the drag due to rolling resistance. The rolling resistance increases slightly with speed, while the aerodynamic drag increases with the square of velocity. For any automobile, as the speed increases, the lift forces increases and the car becomes unstable. To tackle this problem, race cars are designed to produce negative lift or down force. What are the various methods to reduce lift that ultimately produces down force? Click on the points to know more. The drivers themselves use aerodynamics to their advantage on race day. By following as close as possible behind another car, the drafting car will minimize drag and consumes less fuel.